In this video, I want to have a look at differentiating trig functions. So the first one we're going to have a look is the function y equals sine x. So I want to start off just by graphing that function. So we know that sine x starts at 0. It's going to go up to 1 and down to -1 and then back to 0. So that's our function sine of x. Now if we want to find the derivative of that function, we know that the first derivative tells us about the gradient of our curve. So we're going to have a look at the gradient at different points on here and sketch our derivative. So if we do that, our point here, when x is equal to 0, when our angle is equal to 0, we know from our last lesson that when our angle gets really small, when x approaches 0, sine x just approaches x. So the straight line y equals x would have a gradient of 1. And since our function is approaching that line as x gets really small, at 0, our function sine of x is going to have a gradient of 1 as well. So at 0, it's going to have a gradient of 1, so we'll put a dot up here. We know that at this point here, that's a stationary point, so it's going to have a gradient of 0. So put a dot there. Now this one here, we can figure this one out. If we know that here it has a gradient of 1, then at this point here, it's going to have a gradient of -1. Then we have another stationary point here, so a gradient of 0. And the gradient at this point here will be the same as the gradient at the start, because we've just come back around and we're about to start that curve over again. So here we would have a gradient of 1 as well. So if we join our dots together now, we can see our gradient curve. And we can see that that actually looks like our function cos of x. So what that means is if we have the original function y equals sine x, then our derivative, or our gradient, will be cos x. All right, so that's our first one. That's differentiating sine x. Let's have a look this time at starting with the function cos x and differentiating that. So we're going to start with y equals cos x. We're going to draw it up. So we know that it starts at 1, it comes down to -1 and goes back up. So mine looks a bit out of proportion, but that's okay. We'll still get the general idea of the shape of the graph. So now if we draw in our gradients, so the gradient at this point here, that's a stationary point. So our gradient at that point will be 0. Our gradient at this point, just like this one here, will be -1. Our gradient at this point here is 0 again, because it's a stationary point. This point here will have a gradient of 1. And this point up here has a gradient of 0 because it's another stationary point. So if we join those together, missed mine a little bit. Again, mine is a little out of proportion, but you can see that the shape of that is the same shape as our sine curve. The difference is, though, that it's negative. So instead of starting at 0, going up to 1 and down to -1 and back to 0, it's going down to -1 first. So that means that when we differentiated cos, so we started with y equals cos x, when we differentiated, we didn't end up with sine, we ended up with minus sine x. All right, so that's our second differentiation rule that we need to know. All right, so we've got sine, we've got cos. Now we need to have a look at tan. We could do tan the same way, but it's a little bit trickier because of the asymptotes, and what we end up with isn't something we're as familiar with. So let's have a look instead. So we'll start off saying y equals tan x. And we'll use the rule that we know that tan x is equal to sine x over cos x. So we'll have sine x over cos x. And now if we want to differentiate that, we can use the quotient rule. So that means our u would be sine x. And our v would be cos x. Now we know that the derivative of sine x is cos x, so u dash will be cos x. We know that the derivative of cos is minus sine of x. So now when we go to find our derivative, we're going to have v u dash, so that would be cos x times cos x, so cos squared x, minus v u dash, so sine x, u v dash. So sine x times minus sine x would give us minus sine squared of x, which will give us plus sine squared x, all over the denominator squared, so cos squared x. Now you should be able to have a look at that numerator and recognize that as one of your Pythagorean identities. So sine squared plus cos squared is equal to 1. So we've got 1 over cos squared x. And the reciprocal of cos is sec. So 1 over cos squared x would be sec squared x. All right, so that means if our original function is tan x, our derivative is sec squared. So that is our third derivative that we need to know. Now, these are just your most basic trig functions, sine x, cos x, and tan x. Sometimes they get a little bit more complicated. So, for example, if we had, say, y equals sine of 4x, our derivative wouldn't just be y dash equals cos of 4x. We're actually going to have to differentiate this function. So the derivative of 4x is just 4, and that's going to be a multiple out the front. So we're going to have 4 times cos of 4x. So that's going to apply whenever there's something more complex inside there. So these differentiation rules are on your formula sheet, but they look a little bit different because they're stated in a more general sense. So let's have a look at what they look like. So for example, y equals sine f of x. So we've got a function in there, not just an x. Then our derivative is going to be f dash x, so the derivative multiplied by cos fx. All right, if we start with cos, so we've got y equals cos fx. Then our derivative will be minus f dash x of sine fx. And our last one is our tan. So if we start off with tan f of x, then our derivative will be f dash x sec squared f of x. All right, so these guys are on your formula sheet. You need to recognize when to use them and how to use them. All right, so that's a quick look at the differentiation rules for trigonometric functions.